Hello folks, let's come back with this exercise 7.5. Now the problem number 5. We've done till the problem number 4 in the previous videos. So let's check now this problem number 5. In this we see that in the denominator there is this quadratic. So we are going to check if we can break it into linear factors, then we can apply partial fractions and get the integral. So actually it is basically the numerator is also linear and denominator is a quadratic, so you could have gone in for a substitution. It would help you, not directly, but then find out the derivative and try to arrange the numerator in terms of the denominator, in terms of the derivative of the denominator, and so on. That we have done in the previous exercise. You can try that method also, that will also work. But here incidentally the denominator will break into linear factors, so therefore you can apply partial fractions and do the problem. So we are intending to do this by partial fractions since we are in the exercise of partial fractions. So therefore, so let us consider this 2x, or rather let us consider x squared plus 3x plus 2. So according to how we could split it, you could have this 3x split as 2x plus x, and that way when you kind of do the factors, it's x times x plus 2 and 1 time x plus 2 and so on. So therefore you have the factors x plus 2 and x plus 1. As a result, if you could consider the fraction 2x over x squared plus 3x plus 2, it could be converted as 2x over x plus 2 times x plus 1. So therefore you could we know that if you have two linear factors, you can have a and b. That's how you split it: a over x plus 1 and b over x plus 2. This is what we did even in the initial part of the exercise. And that's it. Now we will equalize the denominator so that we'll have x plus 1 times x plus 2. So in order to equalize the denominator, this entire fraction, the first entire fraction has to be multiplied by x plus 2, and the second entire fraction has to be multiplied by x plus 1. So you're getting like it should be a times x plus 2 denominator also, and b times x plus 1 denominator also. As a result, the denominator becomes x plus 1 times x plus 2 in both the cases. So we write a common denominator, and that way when we correspond, we will get that the denominators on both sides are same, so which can cancel each other, and therefore we are left with 2x equal to a times we are left with 2x equal to a times x plus 2 plus b times x plus 1. Now in order to get the a and b value, let x be negative 1. So if x is negative 1, this term is vanishing. You will get a times negative 1 plus 2 is 1, and this is negative 2. So that makes a value as negative 2. And then we'll take x as negative 2. Then in that case, this term will vanish, and you will get b times negative 2 plus 1. That's negative 1 equal to negative 4. So b value is 4. So you got a and b. Now I we can all overall convert. So it is this which is equal to this and which is equal to this. So I can be written as a over x plus 1, which is minus 2 over x plus 1, and b over x plus 2. B is 4. So when we split it, negative 2 dx over x plus 1 and 4 dx over x plus 2. That's very easy. We know that if you have a linear in the denominator, then you will always have log as a integral. So this is going to be plus c. That's all. Now if you want, we can do modifications, like you can call it as x plus 1 log of x plus 1 the whole squared, and then because that negative is there, you can put it in the denominator and so on. So that kind of modifications, then you are welcome to do with whatever that they have given us. So that should be all, because the next problem is a little lengthy problem. We may not be able to fit in over here. So maybe next problem we can do it in a fresh video. So let's meet in the next video. Thank you.